Welcome back to the classroom. My name is Mr. Wong. Today we're going to be looking at a past HSC question that looks at projectile motion, so Module 5 Inquiry 1. This is the 2007 HSC paper for question 16. So we have a group of students investigating which ball bearing released from the various points on the ram would have the greatest ranges. So you can see we have from position A all the way to position G. It drops about 30 centimeters and they record the range. The following is the actual ranges that they recorded based on the vertical heights that they used to find the overall ranges and that relationship there. Okay. So the question that we need to answer in part A is to plot the data from the table and to draw a curve of best fit. Okay, so let's try and zoom out, and whilst I graph this out, you can see the data side by side, and then we'll draw our curve of best fit from there. Okay, so from the data we have here, we have the vertical heights above P, so that's actually our x-axis here, and range over here. That kind of makes sense. Reason being is when we do the graphing, just remember the horizontal displacement is measured by the horizontal velocity multiplied by the time. So it's affected by the horizontal velocity there. This will come into play later on when we solve for the question down here. So the vertical height of 10, we have a range of 32. So each box goes up approximately 2 centimeters. So one box to here is about 2 centimeters. So that's what we have there. So I'm going to graph this all out, and then we're going to try and draw the curve of best fit and see what we can get from there. Okay, so now that I've plotted the data out, we need to draw a curve of best fit. So for the curve of best fit should firstly be on the outers, so should be a line that curves along my data points. Best way I can do it like so. It's not a perfect curve, but it'll have to do. As you can see, I've drawn the curve bits and pieces outside of the first point and a little bit longer after the last point. This will allow us to extrapolate, which is to make predictions outside of our original data set. Question B, it says, use your graph, predict the range of the ball bearing if we released it from a height of 80 centimeters. So at 80 here, that is roughly 92 centimeters. So I'm going to write it in SI units, 0.92 meters. Okay. And then for our second part of the question, we need to calculate the horizontal velocity when the object is released from a height of 80 centimeters. So we know that we know what the displacement is. That's 0.92 meters at 80 centimeters of displacement. Now, we want to find the horizontal velocity. We know what this value is here. So that's good, but we don't know what the time is. So how can I find the time it takes to drop to that point there? And this comes back to what we talk about projectile motion. Whenever an object is launched at an angle, or even in this case here, there is a horizontal component, and progressively there is a vertical component. In order to find the total trip time, it is completely based on the vertical motion of our object. Okay, so the formula that we actually need to use firstly is the vertical displacement, and then from there we find the time, and then we can work our way backwards. So this is the formula we'll need to start off with, and then we need to find time from here. So the question is, what is our vertical displacement? We can see it here, that's 30 centimeters. So if I convert that into meters, it's 0.3. And because we're falling from a height of where P is, this is 0.3. Our initial velocity is 0. So that's half, negative 9.8 t squared. So that's, if we try and solve for that, that's half times the negative 9.8, so negative 4.9. So t squared square root negative 0.3 over negative 4.9. That gives us a value of approximately, or close to, 0.2474 seconds. Okay, so that's the total time it takes for it to reach the bottom here. The range that we have traveled is 92 centimeters or 0.29 meters. So now that I know what the displacement is, I know what the time is, I can find the velocity. So the velocity is this displacement over time. Our displacement is 0.92 over 0.2474, and we get a final velocity, or the initial velocity is about 3.7 meters per second, moving in the forwards direction. And that's how you solve the problem. If you found this explanation useful and you want more videos like this, like, subscribe, and we'll see you next time.